Okay, I'll start today's lecture with talking about the meaning of the left shift and right shift because I got a few questions from you about that. Again, if you, let's say you have a number, so you have a value. So let's say we have a value like a number 0, 1, 0, 1. Okay. And then if we left shift this one by 1, what we get? So we get like basically we left shift whole thing 0, 1, 0, 1, 0, right? So we left shift, basically we add 1, 0 here, and we add 1, 0 here, and so like basically whole thing left shifts. So what's the value of this one in binary? It's 5. And what's the value of this one in binary? It's gonna be 10. So basically left shifting is kind of equal to multiplying by 2. Okay, so if you left shift twice, then it's gonna be like multiplying by 4. If you left shift 3 times, it's gonna be it means like multiplying by 8. So so you know that, and if you right shift again, like let's say if you have let's say 1, 1, 1, 0. If we right shift this one by 1, what we get? We get 1, 1, 1, and that's it. So what's the value of this one? 2, 4, 8, so 14. So what's the value of this one? 7. So right shift is kind of means dividing. I mean, not exactly. I'll tell you the issues with that. Dividing by 2. Sorry, dividing. Dividing by 2. Well, let's look at the few problems with that. It's not exactly correct. I mean, it's kind of correct, but you might have an issues. So let's say you have a number. Let's say you have a 4-bit number. Okay, so like you have a 4-bit number in your and like in like a value. So let's say that number is 1, 0, 0. Well, if you left shift this one by 1, what do you get? So if you left shift this one, so you left shift everything, so you add 1, 0 here, and you shift everything to the left, so 0, 0, 1. So that other one is thrown away. Okay, so this one thrown away. So in this case, what's the value of this one? 12. What's the value of this one? 8. Right? So, well, in this case, it's not equal to multiplying by 1 because, I mean, there's an overflow here, so that's causing an issue. So if you had the same value with an 8-bit system, like a 8-bit like a variable, it was not gonna be an issue, right? 1, 2, 3, 4, 5, 6, 7, 8. If you had the same problem, same number here, well, this is equal to obviously 12, and then if you left shift this one by 1, so it's going to be equal to, again, I'm just going to do it this. So 8-bit here. So in this case, if you left shift everything, it's gonna be 0, like, and add like a 0, 1 0, like you have T0 there anyway. So 1 1 and 0 0 0. So like the 0 in the in the most significant bit here dropped. So here you had 12. What's this value? I mean, this is the border. And like this is gonna be 8 and 16, and so this is gonna be 24. So if you don't have any overflow or something, you know, then left shifting by 1 means multiplying by 2. Left shifting by 2 means multiplying by 4. So if there is no overflow, just keep that in mind, okay? If there is no overflow. Well, I mean, we are not using like we are not using the left shift and right shift just for like multiplication purposes. We really use that very little. We use left shift and right shift and to be able to set ports and things like that, like a bit masking and things like that. So this is not the only application, but just keep that in mind. How about right shifting? Right shifting. So I said right shifting, that means in general kind of like dividing by 2, right? So let's say again, if you have something like this, and if you right shift, you're gonna get 0 1 1 1. I mean, you like this is like basically most like having 0 is either not changing the number, so so it's gonna be like this. So this is like 2, like a 14. Again, this is 7. Like in this case, right shifting by 1 means, you know, means like a division, like a kind of equal to division in in this case. But like if you have something like this 1 1 1, if you right shift this one, so what's gonna be this equal to? It's gonna be 0 1 1 1, right? So what is this? This is 15 obviously, and then this is 7. So this is not exactly dividing by 2, right? So it's not 7 point, you don't get 7.5, you get 7. So again, if number is an odd number, so it's not exactly equal to divide like the dividing by 2. So if it is if it is an even number, you don't have any problem. It works here perfectly fine. But if it is an odd number, it's not gonna work. So if it is an odd number, then it's not gonna work, right? I mean, if you are trying to use it as for a division purposes, it's not gonna work. Well, if you don't care decimal, like a decimal part, then it might be still okay, right? So if you don't care to have just like a decimal part, still does the job, right? So yeah, depending on what you are using and what you are doing, just pay attention, be careful, and be careful and make sure you remember this stuff. And as long as you know what the limitations and you know, like with the overflow here, and you know, like a issue with the odd numbers here, then you will be okay. So I just wanted to remind you that. But in general, we say left shift can mean multiplication and right by 2, and right shift might mean means dividing by 2. So if you look at the programmer's reference manual, there are a lot of instructions, right? So one of them is SL, shift left instruction, So this can do the left shift for us, and we can do like instruct left shift instruction with this. So I mean, we can do left shift operation with this instruction. So there are there's a byte operation and word operation, and it can do, if it is a byte, you do only the least significant byte, and if it is a word operation, the whole word you can do with the whole word. So anyway, so the way it works is, again, obviously what left shift means is you add 0 to the right of the number, and then the most significant bit thrown away. But the one thing you have to be we need to pay attention here is, well, yeah, it's we left shift the number, but then this with this instruction, some of the status affected, so you'll have some flags raised depending on the case. So when you left shift, if there is so like basically whatever number thrown away, let's say if it is 1, then you will have a carry flag raised. Okay, so if the thrown away number thrown away is 1, then you will have carry flag raised, and if as a result of this instruction, if the whole number becomes 0, right? If you shift like depending on the number, but if you shift enough, you can make anything 0, any number 0 with the left shift, right? So you can have 0 value, then what's going to happen is you will have 0 flag raised, and then if you have if number becomes negative, then you will have a negative flag raised. So just so this can be useful. Again, we are not going to do any application with this, but you have an instruction that does shift left for you, and with the implement, like if when you use that, some status affected by that instruction. And here is one example here. Shift left. This is, I'm not sure, is this the format, but yeah. So here is the one example. Shift left. This the value in this location, right? So this is the address in the memory. So shift left value number in this whatever data in this memory location, and put it in wreg0, right? So here we have in this address we have this value, okay, and we left shift this one and we put it in wreg0. So if obviously when you left shift this one, number's gonna get bigger and you will have this one. So you can try yourself and see if that's the result you will get. Of course this one only does shift by 1, okay? It's only shifts 1 digit. Again, there's another instruction. It's in page 416, and you can find it from the list of the instructions. Like in the table, it shows all the instructions in this document. This is again a shift left instruction, and its syntax is shift left, base register, and some literal number, and WND, destination register. So basically what it does, like let's say if you have something like this, again what that means is have the number in W2 left shifted by 4 and put it in W2, okay? So like for example here, we have 78A9. So left shift this one by 4 digit and put it in W2. Okay, so let's do it let's do it and see if we getting the same answer. Again, you can try yourself too. Again, so sorry taking a little bit long here, but okay, so the instruction is here, and again the content of W2 is 78A9. I'm just gonna put them in a binary. So 7 means 0, 1, 1, 1 in hexadecimal, and then I have 8, which is 1. Sorry, yeah, 0, 1. I'm sorry, 1, 0, 0, 0, and then I have A, which is 10, 1, 0, 1, 0. And then 9 is basically 1, 0, 0, 1, right? So if I left shift this by 4, so I'm gonna have so left shift by 4 means like basically I will have like this, all 4 is gonna drop, and I will have 0, 0, 0, 0, right? So I'm adding 4 zeros, and this 4 digit drops. So then I have 8 here, and I have A here, and I have 9 here, and I have 0 here. So obviously that's what we get here, right? 8A90. So what happened here is, well, of course, some flags changed, right? So basically two flags changed. First, number became negative, and also we have a carry bit. So yeah, so that's basically if you need it, you can implement this kind of thing to in your program, assembly program for left shift operation. Okay, so we have this code which shows few loop implementation, and I'll go through this one with you. And so this is kind of a simple application. Basically, what sets the TRISC-B, you know, the direction register, basically makes the port B output, right? So it does it in 2 steps. Like first it moves like a literal 0 to W0, and then moves W0 into TRISC-B, basically sets TRISC-B to 0, so which makes it output. And then of course makes all port B outputs, port B pins output, not like basically the whole thing. And here this basically will make all the pins digital pin, right? Again, this is if we set this register with this value, it makes all the pins. You see this in the lab manual too, in the lab. So you can do, well, you can, it's a good question, can you do this in one step? Can you just set like a TRISC-B with 0? So we will talk about this in a discussion later, but this is fine too, okay? So you might be able to save one instruction doing it in one step. So then you put it in W0, and then from W0 then you assign it to that, and then you set everything to digital. So then here we have a loop, like a 3 different kinds of loop, actually 4 different kinds of loop with repeat. So let's look at these and try to figure out how many instruction cycles it takes, right? So this is the format for the loop. So you have a label here for the loop, and it's so like when it starts and goes through the instructions inside, and then branches here. If branch is taken, so then it's gonna go back. So if like if a value is whatever we got from here is not 0, then because this is the branch not 0, it's gonna branch if it is not 0. So it's gonna basically we are taking it. So then it's gonna go back to loop 1, and whenever the value before branch becomes 0, then it's not gonna take the branch, so it's gonna go to the next instruction here. So let's have a breakpoint here and then run this. Oh, by the way, I should make it default instruction. Give me a second here. Oh yeah, that's yeah. So we are at this point now. So let's move to next. Let's say go through this. Well, I'm not sure what's going on here. Okay, this is my main project, and oh, build failed. Oh, I didn't even pay attention to that. I'm not sure what's set as a main project and set as a main project again. I'm just gonna close this one and let's build this. Build failed. Okay, so there was an issue here. I didn't have a column here, so let's try again. Nope. Let's see. Okay, so I had issues with config file lines here. So now it's working. So now we can go through. So what we are doing here is we are moving literal 5, copying literal 5 to W3, and so now W3 has 5 in it. And so can you tell how many instruction cycles this will take? This loop will take. So let's say you can stop the video and try to figure out how many instruction this loop will take to complete, and then I'll do it with you. So well, when it starts, it's gonna go into the loop and it will go through BTG. Again, BTG is bit toggle. It's gonna toggle the bits in port B to, like, it's gonna toggle the bit 0 in port B. It's gonna make it 1 or 0. So this is what it does. So if you say port B #5, it's gonna toggle bit 5 in port B. Okay, so in this case it's toggling bit 0 in port B. And then decrement, it's decrements the instruction, the value inside WREG3, and WREG3, W3, same thing. Okay, just to remind you that. And well, it's gonna become 4 after this. And again, you can see that actually you can see that if you have WREG3 here. So you can watch it. You can add new watch. And currently it's 5, right? So here on the bottom, again, you can go here, Windows, and you can have watches here, and then when you click this one, you will have tab like this, and you can add, on the bottom you can go ahead and add any register on any variable you want to watch. So then if I move step over, so now it became 4. So well, now the value before branch is not 0, so I have to so branch not 0. Like basically branch not 0, right? So branch not 0. So because we didn't have 0 before branch, so the value before branch is not 0, so that means it's correct. So we're gonna branch will be taken, so we're gonna go back. Okay, so going back means we come back here, so it's gonna go again. So like again, it's gonna flip port B. Again, you can look at port B. So currently port B, I have port B here, so it's added here. So it's currently the first bit is 1. So if I execute that instruction, see, it flipped. So now the least significant bit, it was 1, now it became 0. So then if I continue, the WREG2 is gonna be 3. WREG3 is gonna be 3. Yep. So it was 4, now it's 3. And it, again, this is still branch not 0. So well, we don't have 0, so it's true. So that's why it's gonna be taken. Branch is gonna be taken. So we are gonna go back. So now again, watch here. It's 0. The least significant bit, like bit 0, is 0. So if I execute that, now it toggled again. WREG3 is 3, so if I move, it's gonna be 2, and still not 0, so the branch will be taken. And keep doing it. You can watch the variables as you go. So finally, now I have a bit toggle and decrement, so I will have 0. So now branch is not gonna taken, and it's gonna move to the next instruction. So this, now I basically so now basically we exit the loop here. Okay, so now there's another loop here, and it moves. So let's figure out how many instruction cycles this took. Okay, so well, BTG, if you look at it, it takes 1 cycle, and instruction cycle. Decrement also 1 instruction cycle. Branch will take 2 instructions if it is taken, 1 if it is not taken. Okay, so then we can calculate, right? So we can do the math. Okay, so when we look at here, like again, W3 was 5. So as we decremented, in the first cycle of the loop it became 4, and then later it become 3 and 2 and 1, and finally it became 0. So when it became 4 branches taken, so branches taken here, branches taken, same here and same here, but here branches not taken. So then, you know, like in the first, like we have 1, 2 and plus 2, 4, and 1, 2 plus 2, 4. So we have 4 times, so 4 times 4, and when wreg3 becomes 0 in the final time, it's like BTG is 1 and decrement is 1 and branch is 1, because branch is not going to be taken because wreg3 is going to be 0. So in the final case it's going to be 3. So in total we have 19 instruction. Okay, so we did on paper, we did the calculation and we found that this loop should take 19 cycles to complete. And let's see it with MPLAB X. So I have a breakpoint here, so I'm just gonna run this and it's gonna stop here because my loop starts here. That's why I put the breakpoint here. So now I have a stopwatch here. So it looks like it took like 14 cycles to arrive this point. So I cleared everything. So this clears the stopwatch and this clears the history. Okay, so be careful. So now I'll do step over until I arrive this point, because at this point I exit the loop. Okay, so 1, 2, 3, 4. Yeah, just keep going. And you just watch this. Yeah, so at this point I arrived 19. Okay, so I arrived 19. So it took 19 cycles to arrive this point. So yeah, so you can see same thing from here too. Another way of seeing it is might be, you can have another breakpoint here, so then when you run this, so like when you hit continue, it's gonna go until the next breakpoint. So as it runs, it's the next breakpoint is gonna be this one again, because it's gonna come back and loop back until finally it's gonna hit here. So let's run this. So as you can see, starting from here and coming back took 4, 5. Obviously we did something wrong here. Okay, anyway, so that's we don't have to worry about this one. So we here another implementation of a loop, like basically it does the same thing, but in this case we are not using branch not 0, right? So branch, if it's not 0, we do the looping by like with branch 0, branch if 0. Okay, so here we are using branch if not 0, so it helps us to loop back. But here we are like, let's say we don't want to use not 0 for some reason. We can. This is another way of implementing the same loop, right? So again, you have the same stuff, bit toggle and decrement. So what's happening here is, so here we have an infinite loop, okay, and So here, like every time we, so like like at this point we are checking if it is 0. Well, if wreg is 0, it's gonna jump here, right? So it's gonna jump here. So branch, if 0, it's gonna jump here and basically ends the loop, right? So like ends the whole thing, right? But if it is not 0, then you have an infinite loop, right? So as long as this is not true, it's just gonna skip this one, right? I mean, because I mean, branch is not gonna be taken, so it's not gonna go here. So it's gonna go to the next instruction, right? So that means it's gonna go here. Here it says branch loop 2, so it's gonna go back. So this is like an infinite loop. As long as this is not true, this line will always run, and this will take this branch, like a unconditional branch will take it always back to loop 2. But if this is true, then this, if branch, if you have a 0 here, then it's gonna go here. So basically, then at this point, loop will be ended. Okay, so this is the same thing, similar implementation. It's just the same thing with the like a different implementation. So from here, like in this one, you can count how many instruction this will take, how many instruction cycles it will take to complete this one. Can you do this? Try this, and we will talk about this one. Okay, so let's see if you get the right number, if you did it. So this loop will start. So let's like an initial value for W3 is not 5 in this case, it's 3 here. So pay attention to that. So then here this takes, like, let's start. So this takes one instruction cycle. At this point, wreg3 is gonna become 2 after this instruction. Keep that in mind. So 2 instructions. Well, this branch will not be taken because it's not 0. wreg3 is not 0. So that means 1 instruction cycle. So 1, 2, 3 so far, and this branch will be taken because this is unconditional. So it's going to be 2. So it's 5, right? So 5 instructions. Like now we go back here. So now 1, 2. At this point, wreg is going to become 1. So this is not going to be taken. So 3 and 5 again. So now it became 10, right? So overall, so 5. So like we looped twice now, and each of them 5. So it becomes 10. So now at this point we come back to this point again, and 1, 2, but wreg was 2, so I mean wreg 3 was 1. Now it became 0, so that's why branch is gonna be taken. So it's gonna skip this next one because it's gonna loop here. So it's gonna branch to this point. So that's why 1, 2, and this branch is going to be taken. So it's 2 more, so it makes 4, and it's here. So 5 plus 5 plus 4. So in total we have 14 instructions in this one. Okay, so that's that. And here we have another instruction, so another loop. Let's look at this one. This is basically another loop. So it's increment port B, compare port B, and branch. So what's going on here? Well, this instruction, compare instruction, if you go to the CP, let's figure that out where it is. Let's go to 41. or 46, I guess. Let's find that instruction. Yeah, somewhere here we are getting there. Yeah, so this instruction, so CPF. So this instruction, what it does is computes f minus w reg and update the status. Okay, so this affects these flags, right? So this status is gonna be affected for because of this instruction. So compare, this instruction does not care the result of this, like basically it subtracts f, like here, like f in this case, this value subtracts this from from w0 and like f minus w reg, and based on the result it gets, you know, status pins gonna be, status bits gonna be affected. So actual result is gonna be thrown away. So we don't care like the actual result of this subtraction. What we care is like do we get 0 from here, or do we get negative value or positive value if we have any carry, and if there's an overflow or things like that. So that's why we have this instruction. So what that means then, so like here basically again f minus w reg 3. So like port B at the beginning it's 0, right? We clear it, so it's 0, and w0 is 3. So well, then when you increment port B it becomes 1, right? Obviously it was 0, so it becomes 1. When you compare with port B, so f minus port B, because f is port B, f, like port B is 1 minus, so 1 minus 3 is gonna be negative 2, and which in this case branch not 0, which is gonna be true, right? So we don't have 0, so we have negative 2, 3, you know, like 1 minus 3 is gonna be negative 2, so it's not gonna be 0, so branch is gonna be taken. Then we increment port B again, like comes back, loops back here. So increment port B, so now it's 2 minus 3 is still negative, I mean it's a negative 1, so it's still not 0, so branch will be taken, comes back. And then next iteration, so if this port B is going to be 3, well, then port B minus w reg 3 is going to be 3 minus 3 is 0, so branch will not be taken because this is not going to be true anymore, right? It's branch will be 0, it's not going to be not 0, so it's going to be 0. So I mean, so branch if not 0 is not going to be true, so it's going to exit the loop. So that's going to be the end of this loop. So this is another implementation of loop. So the different implementations, you can, depending on what you do, you can use any of them, one of them. So how many cycles this instruction takes, right? So like at the beginning it's like a 1, this is 1. You can look at the table, but this is like a 1 instruction cycle, 1. So when at the beginning it's like in the first comparison, like in the first loop it's taken, so it was like branch like 1 plus 1 plus 2 makes 4, and then next one, now port B is 2, so that's still so 1 1 2 makes 4, and then final time this becomes 4, and compare result is going to be 0, so this is not going to be true, so this is going to be, so 1 plus 1 plus 1, because branch is not going to be taken, so 3. So like 4 plus 3, so this takes 11 instruction. This loop will take 11 instruction cycle. So this is another loop version. So this you can achieve loop this way. The final one, which is very neat one, and you can use maybe like in the lab too to have like a certain amount of delay. It's really comes really handy. Repeat instruction. So if we go to repeat instruction, again, I'm not sure if I can find it really quick, but I think it's toward the end, but yeah, let's go toward the end of the sorry, it's I should find it earlier, but anyway, so here's repeat. So repeat literal 14 or 15. There's a notes that you can read, like one of them is not for our microcontroller. As you can see, 4 is only available for PIC24, and 5 is only available for PIC25. So this is available for us, so we can go up to 15-bit, okay, literal. So what does that mean? So basically, operation is so repeat the instruction immediately following the repeat instruction literal plus 1 times. Okay, the repeated instruction or target instruction held in the instruction register for all iterations, and it's only fetched once. Okay, so basically what that means is, again, what this does is it repeats, it executes the instruction after that n plus 1 times. So if we say, like for example here, if we say 3, so this instruction like basically it's gonna like repeat 3. Basically it's gonna run this instruction 3 plus 1 times. It's 4 times it's gonna run this instruction. So that's basically what this instruction does, like, you know, kind of a loop, right? So basically it's gonna run if you have only single line that you want to run multiple times, or 1,000 times, 1,000,000 times, whatever, so you can use this one. It's just gonna keep doing it again and again. Again, this is useful if only you want to repeat the next line after this repeat instruction many times. So how long this will take then? Well, repeat is basically taking the number of it takes, like, you have this line will run basically n plus 1 times, right? So like if it is 3 and 3 plus 1, 4, and repeat wastes another instruction just to, you know, fetching the repeat and stuff like that. So then it's gonna be 3 plus 1 plus 1. Okay, so it will take 5 instruction cycles. So we can test it out. Okay, so let's have a breakpoint here. Let me remove any breakpoints here. Looks like there is none. So I'm at this point. Let's see how long it will take to get here, you know. So okay, so stopwatch. I'm just gonna clear everything. I'm at this point now, so I say repeat, and then 1 cycle, so then repeats that, repeats that, repeats that, and I'm at this point right now. So it took like 5 cycles to get here. Again, I'm not executing this one yet. So from here to here, which is this part, took 5 instruction cycles. Again, repeat wastes 1 instruction cycles just to get ready, and then after that and then it repeats next instruction n plus 1 times, like a 3 plus 1 times, which is 4 times. It runs this 4 times. So then for repeat you have 1, and for the running the next instruction n plus 1 times, in this case 3 plus 1 times 4, so 4 plus 1 makes 5. Okay, so that's how you calculate how many instruction cycles this takes. Hopefully that was clear. So 1 plus n plus 1. Okay, and n is the number here. Again, repeat instruction runs the next line, executes the next line n plus 1 times. So all of these are different way of implementing loop. Depending on what you need, you can use one of them. You can come up with yours. You can, if you think a little bit, I'm sure you can come up with the very different loops methods. And so like you can use branch 0, branch not 0. There are other type of branch instructions, so you can use them depending on what you need. So you can come up with clever methods for looping. I hope this helps. Thank you very much. That's all I have for this lecture.